Kusangpo and welcome to Bhutan e-learning project. Today I am here with a lesson, science lesson for class 7 and 8, and the topic of my lesson is turning force and its applications to lever and other simple machine. First, we will look at the lesson objectives. And before I show you the lesson objectives, please remember that at the end of the lesson, we are expected to fulfill those objectives. At the end of the lesson, we are again going to come back to those objectives to see whether we have achieved what we have set. So let's look at the objectives of the lesson. Lesson objectives: define a turning force, identify the use of turning force in our day-to-day life with examples, define a lever, explain how turning force is applied in different types of lever to make the work easier, name other simple machines where turning force is used. So these are the objectives that we are going to fulfill at the end of the lesson. I hope you are with me. Well, let's go ahead. Firstly, what is turning force? What is turning force? But before we go into finding what is turning force, let's try to recapitulate what is force. In class 6, maybe in class 5, you have already learnt about force. And I hope you know what is force. And for your information, the force is a push or a pull which makes a body move, which changes the shape of the body, which changes the direction of the moving object. That we have already learned. But today we are going to go slightly deeper, and then we will be finding about the turning force. So here it goes. The force which makes an object turn around at a fixed axis called pivot is called turning force. It is also called torque. I hope this is quite clear. The force which makes an object move about a fixed point called the pivot. And the other word of turning force here is torque. The effect produced by the turning force is, or the torque, is movement. So turning force we have already seen up there, which makes the object move about a fixed point, and then the effect produced by the force is called the movement. Now, can you guess where do we use turning force in our day-to-day life? Are you with me? Well, please try to guess where do we use this turning force in our day-to-day life. I'm going to give you a few seconds for you to think. Well, I believe you have come up with lots of instances where turning force is used. Now let's look at some examples of turning forces used in our daily life. You can see this: working of a wrench. Another one, seesaw. What is this? Opening and closing of the water tap. Here, closing and opening of the door. In all this, if you look carefully, the force is applied so that the object moves about a fixed point called the pivot. And it's, in other words, it's also called fulcrum. Later on, we are going to look at that. Now, application of turning force in levers. So we are going to see how turning force is used in levers. Before we look at how turning force is used in the lever, it's obvious that we need to know what is a lever. I believe you have some idea about it, but today, through this lesson, we are going to make it more clear. So what is a lever? A lever is a simple machine which makes our work easier. In simple sense, we can say that. Well, what can a lever do? We can move heavy objects with less force by using a lever. It may not be all the time true. Later on, you will come to know that there are different kinds of levers. Some multiply the force, some do not. But we can do, some levers can move heavy objects with less force. That's why we use the lever. Next, to make it even simpler, it is a rigid bar rod resting on a pivot, also called fulcrum, used to move a heavy or firmly fixed load with one end when force is applied to the other. This is the definition. No matter if you don't get this, also we have a picture for you. So let's go and then look at it. This is a lever. You can see the parts. We have a force, which is also called effort. We have a load, and in the middle, what do you have? Fulcrum. But do not think that fulcrum will be always in the middle. Later on, we will come to know what are the different kinds of lever. Okay. Further, there are other parts that we also need to know. Here, we have effort, we have load, and we have fulcrum. But you can see here, load arm. It's the distance between load and the fulcrum is the load arm, and then the distance between the effort and the fulcrum is called effort arm. I hope this makes sense to you. Well, let's go on. Now, let's look at types of levers. Types of lever. Here, you need to be very careful. Please listen and then look at the slides very carefully. Later on, you have some activities. I hope you are with me and you are ready. So, firstly, first class lever. First class lever, fulcrum in the middle. Remember that, fulcrum in the middle. We have already seen which part is called fulcrum, which part is load, which part is effort. So, in the first class lever, we have fulcrum in the middle, and I have put it as F. Let's second class lever. Second class lever, we have load in the middle. Please look at this, load in the middle, L. Okay. Third class lever, effort in the middle, E. So, if you combine these three letters, what do you get? Obviously, flee, F-L-E. But when you learn, what you need to keep in mind is F-L-E. F comes first, L comes second, and E comes at the last. So, F, you can understand that in the first class lever, fulcrum is in the middle. In the second class lever, load is in the middle. And in the third class lever, you have effort in the middle. So, to remember, for you to remember it easily, you can remember FLE. Is that clear? So, please remember this FLE. Now, we have the activity. I am going to show you some pictures, and then you need to identify which class lever does it belong to. I hope it is clear. So, let us go and see. Yes, you can observe it carefully. So, which point are you observing? What is in the middle? Load is in the middle. So, which class lever is it? Well, you have guessed it right. It is second class lever. Because it is second class lever because load is in the middle. Okay, let's go to the next picture again. You can see load, effort, and fulcrum. So, what do you see in the middle? Obviously, fulcrum. So, I hope you have already got the answer. Obviously, since the fulcrum is in the middle, it is first class lever. Very good. Your guess is correct. Let's go on and explore further. Look at this picture. We are concerned with what is in the middle. Here in this case, effort is in the middle. And obviously, since effort is in the middle, it is, yes, you have guessed it correctly. It is third class lever. Congratulations for having participated and got the correct answers. Now, why do we use lever? It makes our work easier. To understand that properly, we need to look at mechanical advantage. And we usually represent it in short with the letter MA. Please remember that. Okay, what is it? Mechanical advantage is the ratio of the force produced by a machine to the force applied to it. When we use the machine, we apply the force to the machine, and machine in turn applies the force somewhere else and does the work. So, the ratio between the force produced by a machine and the force applied to it is called mechanical advantage. And mechanical advantage is used in assessing the performance of the machine, means how well the machine is performing. Is it really multiplying the force? Is it a force multiplier? Is it helping us to do the work easily? That is, to find that, we need to look at mechanical advantage. Okay, the formula for mechanical advantage is mechanical advantage equal to load over effort. In other words, load divided by effort, or in case of lever, effort arm divided by load arm. So, this is the formula we use to find the mechanical advantage. And it is very important, since we have three kinds of lever, mechanical advantage will be different. So, what does this mechanical advantage exactly show us? What does it tell us? It is very important for us to learn. Here, if mechanical advantage is more than 1, we need to understand that force is multiplied by the lever. Means the amount of force that we apply will be multiplied by the lever or the machine. Secondly, if mechanical advantage is less than 1, then we need to understand that force is reduced. In real sense, we apply more force to the machine, but machine in turn applies less to the object. Thirdly, if mechanical advantage is equal to 1, force is neither multiplied nor reduced. Force applied and the force produced by the machine is equal. So, please understand these three things. Mechanical advantage can be more than 1, it can be less than 1, it can be equal to 1. And it depends upon what type of lever that you are using. Well, to understand more, let us take an example to find mechanical advantage. Take an instant, please note it. This is the question for you. We will do it together. If a man applies the force of 250 Newton at the end of a lever and move a rock of 1000 Newton, what is the mechanical advantage of the lever? So, this is the question. Load is given, effort is given. We are asked to find the mechanical advantage. So, I will just show you the simple step that you can practice at home also to find the mechanical advantage. Solution. Well, it is very important that we take the information from the question first. So, what is given? Load. Load is given 1000 Newton. We write it simple. Then effort 250 Newton. Very easy. So, mechanical now third thing is we write down the formula. mechanical advantage is equal to load over effort. Since load is given, since effort is given, we are going to use this formula. So 1000 divided by 250. Finally, we got the mechanical advantage as 4. How many of you got the mechanical advantage as 4? Very good. What does this 4 mean? And no units here. Since mechanical advantage is a ratio, it will not have any units. It's just a number. And the 4 here simply means that the machine, this lever multiplies the force 4 times. Means if you are applying 250 Newton force, machine is making 1000 Newton. If you apply 10 Newton force, how much will it make? Obviously, 4 times 40 Newton. I hope I have made it clear. Let's go further. Now, after having learnt about the turning force, how it is being used in the lever, we are going to look at what are other simple machines where turning force is used. Can you guess for some time? You can note it down. Well, you might have had a list of 5 to 6 objects or 5 to 6 machines which use turning force. Okay, to check, let's look at what is this? You are correct. These are pulleys. So here you can see that pulleys 1, 2, 3, 4. There are different kinds of pulleys that we will be learning in the higher classes. For you, you just understand that, okay, these are pulleys, and then here you can see that the pulleys move about a fixed point, turn about a fixed point. That's why it uses the principle of turning force. Next, what is this? Have you seen this? Obviously, we all have seen this, and it's nothing but these are the gears. You can see that driven gear and driver gear, 2 different types of gears. Okay, so this is also a simple machine where turning force is used. Further, have you seen this? If your parents or if your relatives, anybody is a carpenter, then obviously you have been, I think, seeing this at your home. So you can see the screw going inside a wooden block. So this is also a simple machine where turning force is used. Screw. Okay. How does turning force make our work easier? Now let's look at this concept in general. We talk about turning force, and then we know that force is a push or pull which makes the objects move, but here we are talking about turning force which turns about a fixed point called pivot or the fulcrum. So here, how does it make our work easier? We already said that, now we need to justify it. So what does it do? By multiplying the force, as you have seen in case of lever. Have you seen, we have calculated one, like, when 250 Newton is applied, it was making it 1000 Newton, means it was multiplying the force. So this is the reason why we use the turning force, and turning forces make our work easier in different simple machines. Okay, and then secondly, we have by changing the direction of the force applied. Turning force, we can change the direction. It can be in any case, lever, pulley, even in gears. So we will look at one example of this by changing the direction of the applied force. How does it change? Okay, let's look at. Very interesting. Can you see this? If you consider the blue one as effort and yellow one as load, you see, what is the direction of the load applied? Downwards. The direction of the load is downwards towards the ground, whereas the load is being moved. Object is moved in the opposite direction. So this machine is what? Changing the direction of the force that we have applied. We are applying the force downwards, but the machine is making the object move upward. So this is how it changes the direction of the force. I hope you have enjoyed this. Very good. Let's go on. Change the speed of the moving object. Turning force can change the speed of the moving object. Do you want to see how it changes? How it changes? Let's see. Here you can see the person riding a bicycle. The force is applied on the pedal, and the pedal is moving about a fixed point there called the pivot, and then it depends on how much force you have applied on the pedal, that will either increase or decrease the speed of the moving object. Really interesting, right? So turning force help us in various ways. Let's go on. Okay, finally we have reached to the lesson summary. As I have already said in the beginning, I said that when we went through the objectives, I said that we need to come back and check whether we have really achieved the objectives or not. So that we have already, I have already told you. Now let's do that. Revisit our objectives to check whether we have achieved them or not. So we need to be together. You check and let's see. Define a turning force. Have we defined the turning force? Obviously, yes. So if you are not clear still, you can still go back and then find out. And then you can still find out from different sources. But we have covered here. Secondly, identify the use of turning force in our day-to-day life with examples. We have seen opening and closing of the water tap, opening and closing of the door. We have seen this, so we have achieved this one. Right? Thank you. Define a lever. I hope we have defined it very well. I hope you agree with me. Well, explain how turning force is applied in different types of lever to make our work easier. We have seen first class lever, second class lever, and then third class lever. This also we have achieved. And then finally, name other simple machines where turning force is applied. We have seen other simple machines like lever, pulley, then we have also seen gears, so we have achieved this. So with this, I have something for you to do at home. You can take these questions, and then as you stay at home, please go through these questions and then try to answer them. Very easy questions. It will be very interesting. You can go through Google, whatever resources that you have at home, and then you can do it. Okay. Number one. Question number one. Very easy question. Classify the following into first, second, and third class levers. So I have here 6 objects given: nail cutter, wheelbarrow, tongs, nutcracker, tweezers, and seesaw. So these are the 6 objects. You classify them as first class lever, second class lever, and third class lever. This is the first question. Let's go to the next one. Which class of lever will not multiply the force? Explain based on mechanical advantage using diagram. We have 3 classes of lever: first class, second class, third class, and we have seen how we can find the mechanical advantage. And we have also learned if the mechanical advantage is more than 1, what? If it is equal to 1, what? If it is less than 1, what? We have learned that. So you use that knowledge and then find out which class of lever will not multiply the force. You can use the diagram, you can use the concept of mechanical advantage. Then lastly, but not the least, very important, this is very important and interesting as well. I hope you will enjoy doing this. Identify one simple machine. I'm giving very less work. I don't want to task you with a lot of work. So simple. You just identify one simple machine used at your home and explain how it makes your work easier. You use a lot of things at home. So you can just identify one simple machine. There are so many simple machines used at home. And then you explain how it makes your work easier. So these are the 3 questions for your practice at home. And I'm pretty sure that you have enjoyed my lesson. Thank you very much for attending my lesson. I'll see you next time with another lesson more interesting than this one. Thank you.